Here's the first part of the final exam review, which will correspond to the first part of the final exam. So it looks like looks a lot like our test from Unit 5. You'll have an inequality where you need to pay attention to whether it's dashed or solid. It's going to be dashed if it says it's greater than or it's less than but not equal to. And then when you have y on the left side, it's going to be shaded above for greater than and below for less than. On number 2, you're going to have to graph both lines, and the solution is the place where the two lines cross each other. And for the third one, graph accurately the inequalities and then apply the shading. Remember, the solutions are where the graph shading overlaps. And so if you're not using multiple colors, you can put a big dark S there in the region where both of your shadings overlap. On our last question, multi-part question here, you need to make a few changes. I made a mistake on the title of the table. So instead of cars and trucks, it should be turkey sandwiches and club sandwiches. By reading the paragraph, we can fill in the table because turkey sandwiches use 3 slices of turkey and 4 pickles, but club sandwiches are going to use 2 slices of turkey and 2 pickles. We have a total of 300 slices of turkey and 800 pickles. So each row of the table will turn into an equation. You're going to need those equations for part C. And the graphing will be done for you on the final as well as here in the review. So you're supposed to shade in the feasible region. The feasibility means things that are possible. And of course, you can't have negative club sandwiches or negative turkey sandwiches, so you only want to shade positive X and positive Y, but also you want to shade underneath both lines, because if you shade it above any of the lines, that would mean that you're using more turkey slices than you actually have or more pickles than you actually have. And then on part C, you're going to name a point that is in the shaded region, basically. It's a possible number. Now, it doesn't have to be something on the edge. It can be something well within the shaded region. Okay, so you're going to list your point. So I've listed 50, 75. And then the second part of the question says, show why your point works. That means you're going to plug the X and the Y into both inequalities that we came up with right here and show that they actually produce a true statement. So if it works for both of them, then it's a valid point and we got full credit there. Last part of that is you're going to sell the turkey sandwiches for $10 each for the turkey and the $6 for the club. What combination of turkey and club sandwiches makes you the highest amount of money, the highest revenue, which is you bringing in the money? Now, really, in theory, the maximum can only occur on the boundary. So there are 3 potential points that are listed here. There's 0, 150, that means make all club sandwiches. There's 50, 75, that's 50 turkey and 75 club. And then finally, this point over here, 87.5 and 0, well, that's not really possible when you're talking about sandwiches because you can't have a half sandwich that you're selling. So you would need to go down to 87 turkey sandwiches and no club sandwiches. So you take those 3 points and you plug them into the equation that I created by knowing it's $10 for every turkey sandwich, $6 for every club. And so plugging in those 3, it gives me 3 options, and then pick the one that has the highest number. So when we substitute 50 for X and 75 for Y, we can make $950 in revenue. That means we're bringing in $950. Just make a statement that that is where the highest is and what the highest would be, and we're all done. So this is the end of part 1. There's also part 2 online. Look for that. We'll see you next time.